Hello everyone, welcome back to Module 3. I am Professor Chan. In Module 3, we will be focusing on Chapter 3 from your textbook, and we will talk about trade. So the title of the chapter says, Interdependence and Gains from Trade. And we are going to start with explaining the term interdependence. It's basically the nowadays reality that today's world, anything you consume, you produce, rely on different people from all over the world. And also, if you recall from Chapter 1, the economics principles, we mentioned one principle that's related to trade says, trade can make everyone better off. And in this chapter, Module 3, we will explain why and how the trade can make every party better off through some simple calculation and reasoning. Throughout this lecture, we will be focusing on one trade model. It's a two-country model that we have the US and Japan as the only two countries in our world. And we assume the two countries each can produce airplanes and soybeans. And the only source they need to produce airplanes and soybeans is workers. Okay, so we will use one concept we learned from Module 2, the PPF, Production Possibilities Frontier, to calculate and compare, right, how much each good and each country can produce and consume with and without trade. So if we find out with trade, each country can consume more of each good, or at least one good, we can say that both countries benefit from. Are first, if the US use all its workers to produce airplanes and only airplanes, it can produce 100 airplanes. And if the US put all the workers into soybean growing, then at the end of the year, the US can harvest 5,000 tons of. Now think about, what if we let half of the US workers to work on airplane production and the other half to grow soybeans? So it's pretty obvious that in that case, we would have 50 airplanes, right? Half the amount because we're using half of the total workforce, right? So we have 50 airplanes, and at the same time, with the rest of the workers, they produce 2,500 tons of soybeans. Okay? So with those information, we can actually derive the PPF for the United States. So if we draw a coordinate, right, and put soybeans along the horizontal axis, and we put airplane along the vertical axis, we can find or denote the intercept along the y-axis or airplanes axis 100, because it's assumed that when the US economy uses all its resource, all the workers to produce airplanes, which means 0 tons of soybeans, it produces 100 airplanes, which is exactly this point D means, right? At point D, we have 0 tons of soybeans and 100 airplanes. At the same time, if the US decide to put all its resources, which is workers, to grow soybeans, then we can get 5,000 tons of soybeans. And if that happens, we have 0 airplanes. So that's what this point A is about, right? And if we connect point D and point A, the curve we got is the PPF, the Production Possibilities Frontier. And point C is the midpoint, right? It's when we use half of the workers to produce airplanes. We got 50 airplanes. And at the same time, we have 2,500 tons of soybeans. We can also derive, right, the coordinates of point B by considering if we're moving from point C to B, what happens is that we are producing 12 less airplanes, because 50 to 38, right, that's 12 less airplanes if we observe from along the y-axis or airplane axis. Okay, and moving from point C to point B, right, while we're reducing the production of airplanes, we're also increasing the production of soybeans from 2,500 to a certain amount we calculated is 3,100 tons of soybeans. How to do that? We know that when we, is the rate of exchange between airplanes and soybeans is 100 airplanes, right, equals 5,000 soybeans. Because either way, we are utilizing all the resources, right? Because point A and point D, they're both right on the PBF. So, which means every point on the PBF, A, B, C, or D, they are using the same amount, which is all the resources, all the workers. Okay? So when we are, say, instead of producing 100 airplanes, right, we use all the workers, switching from airplane production to soybean production, right? So the rate of exchange is 100 airplanes can transform, in a sense, right, into 5,000 soybeans, because that's exactly what all the U.S. workers can do, either 100 airplanes or 5,000 soybeans, right? So which means for each one airplanes, we can, like the workers who can make 1 airplanes, they can also make 50 tons of soybeans. Make sense? So that's like the rate of change. So when we are reducing 12 units of airplane production, then how much more soybeans we could produce, right, with the workers, right, switching from airplanes to soybean production is 12 times 50, which equals 600 tons more soybeans. And if we add the 600 to 2,500, we got 3,100 tons of soybeans. So that's the point B, So in this way, by calculating this way, we're making sure that the resources, the total workers that are producing, right, at point C and point B are the same, because A, B, C, and D are right on the PBF. So they are all of them are the points that utilizes all the workers. It's different from any point inside or outside the PBF. Then, if you're inside, you're not utilizing all the resources. If we see a point outside the PBF, that's not a feasible point. If you're still not feeling comfortable about how we calculate, right, the coordinates of point B, that's okay. I think you will have a better comprehension after we talk about the concept of opportunity cost. Okay, but just keep in mind that point B is also a point along the PPF. Okay, so that's also one of the situations that the US can do the best with its resources, the workers. Okay, now let's take a look at the Japanese economy. So for Japan, their workers can also produce airplanes and soybeans. And if they let all the workers focus on airplane production, they can produce only 48 airplanes. How about let all the Japanese workers focus on soybean growing? Well, unfortunately, it's just 1,200 tons of soybeans with all the Japanese workers. So if you recall that those numbers are much smaller than the US workers, capabilities. Now let's also consider, what if we put half of the workers in airplane production and the other half to focus on soybean growing? Then instead of 48, half of the workers, the total workers, will produce 24 airplanes. And the other half will produce exactly 600 tons of soybeans. Okay, so we can also plot these points on a Japanese PPF, right? This point D here denotes when Japan decide to, produce 0 tons of soybeans, then it can have 48 airplanes. Or let's focus on soybeans, at point A, when Japan produces no airplanes, the maximum amount of soybean they could produce is 1,200 tons. And this point B here could also calculate it with a similar concept to the opportunity cost that you don't need to worry too much about. I just put this point here so that we can later on compare to it with a scenarios that allows for trade, specialization, and trade. However, one thing for sure we know is that, we can derive the PPF according to the information given on this page, And we know that point A, B, C, and D, they're all right on the Japanese PPF, which means all the points are efficient, All the points are, different combinations of airplanes and soybeans that are utilizing all the resources, the workers. Another term that is very important when we are trying to understand how trade works is called absolute advantage. It describes the ability to produce something, using fewer inputs than other producers. So what does that mean? Let's take a look at our example, The US and Japan model. So recall from previous slides, the US workers can make 100 airplanes at their best, If everyone is working on airplane production, the US can make 100 at most. While for Japan, they can only make 48 airplanes. Even though everyone is working on airplane production, no one's growing soybeans, they could still make less than the US. So in that case, we say the US has absolute advantage in airplanes. Okay? Now think about when speaking of soybean productions, who needs like less costs, right? Just fewer inputs. Consider for the US, the whole economy can grow 5,000 tons of soybeans, while Japanese economy could only produce 1,200 tons at their best. So it is obvious, according to the definition, that when speaking of soybean production, the US also have an absolute advantage. Looks like we got a problem here. See, from last slide, we realized that the US has absolute advantage in both airplanes and soybeans production. So does it mean the US should do all the job and let Japan just sit there and wait? That is not true. Even though the US has absolute advantage in both goods, there is still chance to trade. Because specialization and trade does not depend on absolute advantage or AA. Instead, parties trade according to something called comparative advantage or CA. Okay, so what is comparative advantage? So basically, the difference between CA and AA is that AA is just comparing the number, right? How much cost that occurred when producing different goods. But comparative advantage is considering costs from an opportunity cost perspective. So if you recall from chapter 1, opportunity cost is the cost when cost is what you give up to get something. So opportunity cost is usually not like never realized, because it's something that never happened, right? It's the alternative reality. Is what you could have earned, right? If you didn't choose certain option, if you didn't do something, if you didn't get something, right? But in reality, you do choose, say, option 1, and you give up all the benefits of option 2, then all the benefits of option 2 is exactly the concept of opportunity cost. Okay, from here, so how do we use the term or the concept opportunity cost to help us understand trade? So in our example, we define the opportunity cost, say, of an airplane as the amount of soybeans that could be produced but didn't really, right, being produced because we choose to produce airplanes. So when we do that, how much soybeans we actually are giving up. That's the opportunity cost of an airplane. We can actually use graphs to help us calculate the opportunity cost. So I use OC here to be short for the opportunity cost. Okay, now recall that according to the PBF of the US, right, when we're giving up 100 airplanes, we can actually use those workers to produce 5,000 tons of soybeans, right? So we can write the opportunity cost of 5,000 tons of soybean equals 100 airplanes. And from there, right, so we have this equation in the first row. From the first row, if we divide both sides of the equation by 5,000, then the left-hand side of the equation will be left with 1 ton of soybean. And the right-hand side will be left with 100 divided by 5,000 airplanes. Which equals 0.02 airplane. So 0.02 airplane is the opportunity cost of 1 ton of soybean. So from this same equation, we can also say that the opportunity cost of 100 airplanes is 5,000 soybeans, right? Because if we're producing 100 airplanes, then we are also giving up the opportunity to produce 5,000 tons of soybeans. Okay, so the same equation actually as in first row, 5,000 tons of soybean equals 100 airplanes. That is to say, 100 airplanes equals 5,000 tons of soybeans. So if from here we divide both sides of the equation, this equation, 100 airplanes equals 5,000 tons of soybean, right? Then we have opportunity cost of 1 airplane equals 5,000 tons of soybean divided by 100. So if we simplify this term, we have 50 tons of soybean, which is exactly, right, how much soybean we could have produced, but instead we choose to produce 1 airplane. So that's the definition of the opportunity cost of 1 airplane. And according to our calculation, the opportunity cost of 1 airplane is 50 tons of soybeans. So similarly for Japan, right? We know that Japan can choose between either put all the workers in airplane production and produce 48 airplanes, or let them all focus on soybean production. So Japan can produce 1,200 tons of soybeans, right? So the trade-off between airplanes and soybeans is 1,200 tons of soybean equals 48 airplane. Okay? Now, if we want to calculate the opportunity cost of 1 ton of soybean, then we divide this equation here. 1,000 tons of soybean equals 48 airplane. We divide both sides of this equation by 1,200. Okay? So the left-hand side will be left with 1 ton of soybean, and the right-hand side will be left with 48 divided by 1,200. Okay, and if you simplify this term, you would have 0.04 airplanes. And that is the opportunity cost of 1 ton of soybean. Okay? So what about the opportunity cost of 1 airplane for Japan? So we can start from the same equation actually, right? But this time we write The opportunity cost of 48 airplanes equals 1,200 tons of soybeans. Okay, so now we divide both sides of this equation by 48. Okay, so the left-hand side will be opportunity cost of one airplane, and the right-hand side will be 1,200 divided by 48. And if we simplify this term, we got 25 tons of soybean, and that is the trade-off relationship or the rate of exchange between airplane and soybean for Japan. Okay, so in short, when Japan produces 1 unit of airplane, at the same time is giving up the chance to produce 25 tons of soybean. Now let's summarize the results in this table, right? The opportunity cost of producing 1 airplane for the US is 50 tons of soybeans based on the previous slides, right? And the opportunity cost of producing 1 airplane for Japan, according to calculations in previous slides, is 25 tons of soybeans. Okay, just copying number from previous slides, we know that opportunity cost of 1 ton of soybean for the US is 0.02 and for Japan is 0.04. Okay, so now let's consider within each industry. So basically in this world, there are only 2 economies and only 2 industries. One is airplane industry, the other is soybean industry, right? So in airplane industry, right? So we're looking at this column here. Who has lower opportunity cost will be considered to have a comparative advantage. Okay, so according to the definition, Japan has a lower opportunity cost of producing 1 airplane, right? Because 25 is smaller than 50. So I just color this 25 tons of soybeans red to represent, okay, it's the lower opportunity cost in the airplane industry. Okay, and at the same time, speaking of soybean production, the US has a smaller opportunity cost because to produce each ton of soybeans, the US only give up 0.02 airplanes. But for Japan, it has to give up more. It has to give up 0.04 airplanes. So just by comparing the numbers, we can say, okay, speaking of soybean production, the US has a lower opportunity cost. Therefore, the US has the comparative advantage in soybean production. So that's what this table is trying to say. And that's how we can identify, right, which country has the comparative advantage in certain industry. We just compare the 2 numbers, right, within each industry. Which country has a smaller number, then that means it has a smaller opportunity cost, and that means it has a comparative advantage. So the principle of comparative advantage shed light on how do we specialize in trade. That is, the parties in an economy, countries or individuals, they always produce according to their comparative advantage, which means they focus on the industry that they always have a smaller opportunity cost compared to their competitors. That is, in this case, in the airplane industry, right? Japan faces a lower opportunity cost to produce one airplane compared to the US. So following the principle of comparative advantage, Japan should focus on airplane production. And for soybean production, the US has a smaller number, has a lower opportunity cost. That is to say, the US has comparative advantage in soybean production. So, again, following the principle of comparative advantage, the US should focus on soybean production, which is perfect, right? In this case, we have two countries, we have two industries. No, Japan focuses on producing airplane because its opportunity cost of producing airplane is lower than the US. And the US focus on soybean production because the opportunity cost of producing 1 unit of soybean is lower for the US comparing to Japan. Next, we're going to use a little more calculation and math, to compare the consumptions of each good for each country with and without trade. Recall that the principle of comparative advantage says, right, countries should specialize on what industry that they have a comparative advantage. Okay? So, according to this table here, Japan focuses on airplane and the US focuses on soybean, which brings us to the case when Japan used up all its workers to produce airplanes and it got 48 airplanes. And at the same time, the US would let all its workers to grow soybeans. And in that case, the US will produce 5,000 tons of soybean for the whole world. So that is called specialization, that each country only focus on what it's good at the most. But if we only allow for specialization but no trade, then the US could only have soybean, even though it's so good at growing soybeans, but they still need some airplanes. And the same for Japan. They're good at airplanes, and according to principle of comparative advantage, they use up all the resources, workers, to produce 48 airplanes. But what do they eat? They eat soybeans. So the only way to make that work is to allow for trade after, right, each country specializes. So in this case, we let US to import airplanes at the cost of soybean, right? So they export soybeans. And we let Japan import soybeans at the cost of airplanes. So we set the number specifically, right, to reflect some points that we already note along the PBF of each country, okay? So we say the US want to end up with 38 airplanes. And both countries agreed to trade one airplane for 40 tons of soybeans. The TS here is short for tons of soybean, just to make the notation shorter, okay? And let's see what happens from there. So first, we can calculate after allowing for specialization and trade, how much soybeans the U.S. can consume and how many airplanes the U.S. now have. So with the trade, the U.S. have to pay Japan with 1,520 tons of soybeans. So it's left with 3,480 tons of soybeans. But at the same time, it gets 38 airplanes. Okay? And for Japan, they trade 38 airplanes for 1,520 tons of soybeans. So now that they're happy with the soybeans they get from the US, and they're okay with just keeping 10 airplanes, even though they produce 48 at the first place, because they specialize in producing airplanes. Okay, now recall from the very beginning of this lecture, the PPF, we can actually, denote or find out the bundle for US and for Japan, right? When the US produces 38 airplanes, it can only grow 3,100 tons of soybeans by itself. We call it a autarky economy, an autarky, when the economy produces and consumes. So it's a self-sufficient economy, right? And from here we can already compare, right? Even though the US are consuming the same amount of airplane, but with trade, specialization and trade, the US can consume more soybeans, 3,480 tons of soybeans. That's more than the autarky or no trade consumption of soybeans, which is 3,100 tons. Okay, and for Japan, we just set the number so that it's easier to compare, right? When Japan consumes 10 airplanes in a closed economy, when there is no trade, the leftover workers will let Japan produce 950 tons of soybean. However, with trade, Japan still keeps 10 airplanes, but the US pays Japan 1,520 tons of soybean, which is much more than the no trade situation, than the autarky situation. So in this case, right, after trade, both countries, both Japan and the US, are better off. So we can draw the conclusion, right? Like we mentioned at the beginning of the chapter, trade can make everyone better off. And we proved this statement with the calculations based on the model given. Okay, and think about that. If we also denote the point with trade as point E on the US PPF figure, right? The point E is actually here. When the US, with trade, the US can keep 38 airplanes, while having 3,480 soybeans. So this point E here, right, corresponds to that bundle is above the old PPF. So that's another proof, graphically, that the US is better off with trade, because with trade, the consumption bundle of airplanes and soybeans will be at E, which is beyond its PPF, right? So that's an improvement. That's a proof that the US is better off with trade. So the same story for Japan, right? If we plot the consumption bundle of airplanes and soybeans for Japan with trade. We have this point E here, right? Where Japan can keep 10 airplanes and gain and import 1,520 tons of soybeans from the US. So it's point E here, and it's way beyond Japan's PBF. That means Japan is also very happy with trade. So the final takeaway of this chapter is that while each country or individuals specialize in certain industry or good according to its comparative advantage, the total production is higher because specialization allows for higher efficiency. So in that case, the world's economic pie is bigger. So everyone is better off after trade. And every party, countries, or individuals can actually benefit and gain from trade. So this concludes chapter 3.